Previously on this old Tony. Less previously on this old Tony. Next time on this old Tony. All right, Houston, we have X-axis. Before we even get started, can we stop a minute and listen to that beautiful sound? I've actually recorded this and now use it to get to sleep at night, instead of my usual 10 CD collection of whale song. That is the soul-cleansing sound of ball screws pushing cast iron on decadently lubricated dovetail ways. In comparison, let's hear that Acme screw on the Z-axis one more time. Hold on, old Tony. How'd you get that X-axis converted so quickly? I might be asking myself out loud in the third person. Well, I'll have you know this ain't my first axis conversion. That, and just like the 7th time I took my driving test, I lucked out and this turned out to be way easier than what I'd planned. This is the original Acme screw that came out of this machine, bronze nut and all, still in really good condition. This flanged nut used to fit in this bore here. It just pushed in, or 4 socket head cap screws kept it in place. Your standard recirculating ball nut is just a little bit bigger, but I'd measured that and it looked like I could bore out enough material to fit it in this same location. Keeping it in that same location sounded wise. Anyway, I'd already gone to a lot of trouble to figure out how I'd set this up on the milling machine. It's kind of a big, awkward casting, but I think I had a way to set this up with the milling machine in horizontal mode, get everything lined up nice and square, bore that out, and drill more holes. As luck would have it, I was able to source an invisible ball nut that fit perfect. You remember this thing? The hydraulic locks I went on and on about a couple of videos ago? Well, I'm not using these anymore. So I had a big gaping chasm in this side of the casting that was ripe for taking advantage of. I figured I could just make a big bushing, like the one you're seeing here, and install the ball nut in that. When I got to wondering, hey, could I just modify the old hydraulic brake? Use that as my bushing? Turns out I could. Two videos in a row. What are the odds? This is cast iron, which is why you don't see me using cutting fluid. I think it's cast iron anyway. Either that or it's the worst steel I've ever come across. What do you folks think? Is that enough holes for this part? Leave a comment down below if you think I should add a few more holes. That was basically it for the X-axis conversion. Crazy, huh? Then it was just a matter of attaching the servo, which I did with 4 standoffs. I took this end cap off, drilled 4 holes, made 4 standoffs of the proper length, and here we have it. Heavens me, I almost forgot the most important bit. The thrust bearings that keep the screw in place. At the end of the screw, inside of this end cap, there's a thrust bushing pack that keeps the screw rigid to the table, but allows it to rotate freely. To state the obvious, X needs to translate perfectly with the table with no slop in it, no backlash. But again, miracle of miracles, that just fell in my lap too. You see, with the new screw, I thought I'd have to rework this entire end cap. But as it turns out, the original screw had a hardened bushing with all of the smarts pre-installed. It was one heck of a shrink fit. You can see the bushing has discolored a bit because of the heat. But once warmed up, it came right off, and I installed it on the new ball screw. I mean, I did have to do some machining on the new screw to get the features to match and the shrink fit to work, but that bushing saved my bacon. The bearings in this end cap are still in great shape, so it all sort of worked out. If you're hating me right now because I'm beautiful, keep in mind that y-axis is more than likely going to be paybacks. This is one of those rotating nut translating screw arrangements, and we'll need a new bearing pack fitted, which is going to stink, but we'll smell that in the next video. If it makes you feel any better, I did mess up the far end of this x-axis conversion. This is the other end cap on the other side of the table. There's another bearing here, a snap ring, and some of that screw sticking out. This should have been like a 1/4 inch deeper. There's a plastic cap that would have sealed this off, but I was mixing my units. I don't know what happened. I could have sworn at one point I laid them side by side on the bench too, and they were the same exact length. Fortunately, there's no shoulder or bearing seat in there. That's just a precision through bore. Like the OD of that bearing would just slide back and forth in this end cap. That keeps the screw centered, keeps it from whipping around, but doesn't over-constrain it, which is fortunate because the rapids on this machine now are going to be so fast. That will help mitigate some of the relativistic effects when the length contraction starts to take effect. Nonetheless, I would have preferred if that were sub-flush and I could put a nice plastic cap in the end. While we're here, I used a shaft coupler to connect the motor to the screw. That's a standard 3-piece coupling, a little on the small side, but that's what I had on hand. I think this is made for a 5/8 inch shaft, max. This motor is 19 millimeter, about 3/4 of an inch, and by the time I cut the keyway in that, there's not much meat left on the coupler. It should be fine though. I mean, at least until it ain't. I'm also not entirely sure I use the right kind. This is one of those rubber spider style couplers. Not sure how suitable that is for CNC. I might need one of those accordion style ones. Excuse the technical jargon. But there's no accounting for taste, and there ain't no stopping progress. So if we have to do it all over again the right way, well, so be it. What I'm about to do here is completely premature, but hopefully you all know by now I'm a big fan of jumping the gun. I'm going to try to measure the backlash. I wish I had a longer indicator, but that's the best I've got in metric. That's like a 3/8 inch metric indicator. This is old German iron. Metric is its native tongue. I've been doing the conversion in metric. Mach 4 software is talking in metric, so this is just convenience. Doesn't really matter. But anyway, the gib's not snugged up yet. The machine is definitely not properly lubricated. And most importantly, the tension on the thrust bearing on the other end, well, it isn't really set. I just sort of snugged it up when I put it together. That said, let's try this anyway. I'm going to bump the machine a millimeter at a time, 40 thou at a time. We'll do 9, 10 millimeters, and then come back to 0. Hopefully anyway. Is there a doctor in the house? That, if I'm doing my math right, is 4 thousandths, maybe even 5. And that's terrible. Granted, I didn't torque that bearing pack, but there's no way it's adding 4 thou. I might have just answered my own question about that motor coupler. Rookie mistake. I also think I noticed the indicator wasn't showing full 1 millimeter increments. Go back and watch that indicator face closely. You'll notice it lose, I think, 1/100th of a millimeter each turn. I haven't done a full axis calibration in Mach 4 yet, not to mention the mag base on the indicator is mounted a bit precarious. It could have shifted with the accelerations on each move. That's all to say, we still have a lot to talk about, but for now, 2 down, 1 more axis to go. Then the spindle, then wiring probably. I've really got to sort all this stuff out. My garage is looking like the set from a Mission Impossible movie. It takes me 10 minutes to get 10 feet, sneaking over and under all the tripwires. Good chat, folks. I'm glad we finally made some time to sit down and talk. Hope you're all doing well. Thanks for watching.